This is Mr. TG. This is section 9.1, Algebra 2B. Today we're going to be starting our chapter off with sequences. And we're going to be talking about two special types of formulas. They're going to be explained in a little bit, but first I thought we'd just talk about what a sequence is. In front of you on your notes you can see a list of numbers. We call those a sequence because there's a certain pattern. As you can see in problem number 1 here, the pattern goes up by 2's. I think most of you can tell pattern just by looking at the sequence. 2 goes up by 3's. 3, the pattern goes up by 4's. It does make a difference where we start. This one started on 2, this one started on 4, and this one started on 3. And then in this case, in number 4, we're multiplying by 3. 3 times 1 is 3. 3 times 3 is 9. 3 times 9 is 27. 3 times 27 is 81. Now, to express these sequences and find out what future terms are, we can use formulas to do this. The first formula I'm going to present to you, and Pearson will also present these formulas all to you in a different way. The first formula is called the recursive formula. Now, a recursive formula, as it says here, defines each term by relating each term to the one before it. That simply means that if I want to find out what the next term is in my sequence, like if I want to know what the next term in this first sequence, I have to identify the pattern. What am I adding to the previous terms to get that? And of course, we're adding 2 each time. So that would be a 12, that would be a 14, etc., etc. If I wanted to do number 4 with the recursive formula, we would have to multiply by 3, so because we're multiplying by 3 each time. So that would be 243 as our next term, and we would continue to multiply the previous number by 3 to obtain your next term in the sequence. With recursive formulas, it does matter which term where you start. If I started number 1 at 1 and added 2 each time, I'd end up on a completely new set of numbers. They would each go up by 2, but they would end up being the odd numbers, 1, 3, 5, etc. Now, the next type of formula is called the explicit formula. And this will be new for some of you, most of you actually. The explicit formula by definition is each term in the sequence. You can define each term in the sequence by relating it to the term that you are on, not the previous term. So we're not real too concerned in this case with the previous term with the sequence. What we are looking at is this. If I want, I'm just going to make this list a little bit bigger here. I got 2, 4, 6, 8, etc. I'm going to call this my first term, second term, third term, and fourth term, etc. And I'm going to ask myself, what can I do to the term that create the value in the sequence? And I think it's pretty obvious here that if I double the first term, I get 2. Double the second term, I get 4. 2 times 3 is 6. 2 times 4 is 8. This is very beneficial because now we're going to call the next term the nth term. And then I can identify the value of that term just by simply taking 2 times n. Then they get a little bit more challenging. But once again, before I move on, we did not look at the previous term here. We looked at the term that we are on. If I look at number 4, I got 1, 3, 9, 27, etc., etc. This is the first term. This is the second term. This is the third term. This is the fourth term. What I want to be able to do is call this the nth term and have an expression that will create its value. And like I said, this one a little bit more challenging. If you do a lot of guessing and checking, you would end up with 3 to the n minus 1 value. If I put the first term 1 in for n, 1 minus 1 is 0. 3 to the 0 power is 1. If I put 2 in, I get 3 to the first power, which is 3. If I put 3 in, 3 minus 1 is 2. 3 squared is 9. If I put 4 in, it's 3 cubed, which is 27. So you can see that now all I have to know is what term I'm on. I don't need to go to the previous term, and I'll just take 3 to the n minus 1 power. These are much more challenging to come up with in certain situations, and that's one thing we're going to practice in this chapter. So there you have it. Recursive formulas, I think, come to us naturally. The explicit formula, we are going to have to work on it a little bit with just a little bit of practice. So that introduces the section 9.1. I'd like to have you watch the two Pearson videos. They do an excellent job of the type of notation we use with these. And then we'll finish up with one of my videos where we do a couple examples of problems that you'll have to know. And good luck with this, and I hope it goes well.